So you only had to do 2, 3, and 4. If you did number 1, that was fine. So let's start at number 2. Check your work with mine. Okay, so for number 2, you have to distribute first. We have 8 minus 6x minus 18 is less than 4x minus 5. You could combine your like terms or start to move, either or, doesn't matter. 8 minus 18 would give us a negative 10. If we moved, let's say we moved the, 6x over and the 5 back over, we'd end up with negative 5 is less than 10x. If that's not how you did it and you did it the other way, that's okay. When you divide both sides, you get a negative fraction. You can either leave it as it is or read it backwards or flip it, either or. So then when you go to graph it, you have different options since you have a blank number line. You could put negative 1/2 in the middle and then just count by whole numbers. So I can say this is 0, 1, 2, 3, and so on and so forth. And then negative 1, negative 2. You could have just counted by ones and then put negative 1/2 in between. Either or, it does not matter. So this would be an open circle going to the right. Questions on that one? With number 2, they're asking about which of these fall in the solution set. So you have to solve it first. So distribute, that would be 18 over 3 is 6, and 30 over 3, negative 10. Get all your variables on the same side. And divide. Again, this will be a fraction. 1/3 is less than x, or x is greater than 1/3 if you want to switch that around. So looking at these numbers, you can either draw out a number line or you can just think about which of these would be greater than 1/3. 1/3 would not work because it doesn't have the equal to. Negative 1 is not greater than 1/3. 1 is, 2.5 is. Questions on that one? And then the last one, if you got to this one and you solved it, you may have seen something that was a little weird. I'll explain what that is here in a second. So solve this like normal. So I'm going to combine my like terms to get 18. And then distribute. If you were thinking this looks similar to like a no solution type thing, you're on the right track, but it's not what it's called here. So keep solving. So we could subtract the 18x, add 7 to both sides. Everything on this side would become 0. This side would just become 15. And instead of thinking no solution, infinitely many, you really just have to think, is this a true statement or not? Is 0 greater than 15? No. So because that's not a true statement, you would just say this is false. You wouldn't say no solution. Questions on that?
Have we done false statements before?
No. So you won't really see anything like that. This was just something I wanted you to see on a just in case. I'll say yes and no. We've done it some in solving equations in general, but not with inequalities. Okay. I'm just going to pull up this definition so you can write it, but then we won't do anything else until after lunch. Because today we're going to be talking about compound inequalities, which are two inequalities or more joined together with and or. So when we get back, so first let's talk about or inequalities. Or inequalities have a tendency to graph apart. So on our practice, on our quizzes, on our tests, or inequalities will have a tendency to graph apart. No, did that sharpen or not?
Huh?
Did that sharpen or not?
Yeah.
Okay, I was going to say there's little ones in the colorful trays. Alright, so if we got this as our final answer, x is less than or equal to -2 or x is greater than 3, we would graph both of these on the same number line. So we would have a closed circle at -2 going to the left, and an open circle at 3 going to the right. So they're going to graph apart. And then our interval notation from last class, we're still reading left to right. So from the left, this would keep going towards negative infinity. It would go until you hit -2, which would be a bracket. Then you would put or. It starts again at 3. That's open, so it's a parenthesis. And then it keeps going towards infinity. So after we solve them, we're going to graph them, and they're going to look like this. And then the interval notation is also going to look like this. Questions about that before we actually try some? So let's try number 1. With our or inequalities, we're going to solve both of these inequalities separately. So what we do to one, we do not do to the other. Solve them as two separate things. So for this first one, we would add 4 to both sides. For the second one, we would divide both sides by 2. Once you have your final 2 answers, put an or in between them. So that is your inequality answer. And we could graph this. Open circle at -3. Closed circle at 6. Facing away from each other. Then if we were writing our interval notation, where would this one start? Where would it stop? -3, would that be a parenthesis or a bracket? Parenthesis. Then the word or, it would start at 6, would that be parenthesis or bracket? Bracket. And then it goes all the way to what? Where does it end? Infinity. With a parenthesis. Do we have any questions about that one? We're going to do one more of these type. Let's try number 5. So for number 5, again, solve them both separately. I'm going to show you 2 different ways how to solve this one, but we'll do one, solve everything, graph it, and then come back to the other. So if we were distributing this, it would be -6x minus 3 is less than -15. solve that completely. So add 3 on both sides. So we get negative 12. Divide both sides by negative 6. Remember that when you divide by negative, your sign changes direction. And then go back and solve the other one. So here we would subtract 1. And remember that this is really negative 1x, so we can divide both sides by negative 1. And again, your sign would change directions. And then you could do one of two things. Either write the or in between these as is, or write it in the order so it would be the one that's less than first and then greatest, like this. Either or does not matter. And then we can graph that. X is less than or equal to negative 4. Close to the left. X is greater than 2. Would be open to the right. Even if you left it as the original, you would still get that same graph. How would we write our interval notation? Where does it start? Keep looking left. Where would that start? Negative infinity. And then it stops at negative 4, and that would be a parenthesis or a bracket. Or starts again at 2, would that be parenthesis or bracket? Parenthesis. And then it keeps going to infinity, so that would also be a parenthesis. There is one there, it's just kind of hard to see. Right. Questions on that before I show you the other way we could solve the left half? So somewhere where you have space, it could be in this open box right here. I'm going to do a different way to solve this part. I'm going to rewrite it first. If instead of distributing, I saw that 3 is divisible, or 15 is divisible by 3, I could divide both sides by negative 3 first instead of distributing. And that would just give us, we don't need the parentheses, 2x plus 1. But because we divided both sides by that negative, the sign does still change. And then we would keep solving. Subtract 1 on both sides. Divide by 2 on both sides. So we get the same thing no matter what. It's just preference. If you see that 3 goes into 15, you could do this. If it was like a 2 and a 15, you could not do this. Questions on 5? Okay. So let's go to the next page and we're going to talk about the other type. So once you finish writing that down, go to the next page. Okay. You have to think about or and inequalities as complete opposites. If or inequalities have a tendency to graph apart and inequalities have a tendency to graph together. So an example of that would be this. here we have x is greater than or equal to -6 and x is less than or equal to 1. I'm going to graph both of these like normal. Closed circle at -6 going to the right. Closed circle at 1 going to the left. These two lines will overlap each other at some point. The overlap is what we're looking for. So as you are practicing, you can keep using the two lines and then draw in the overlap, just the overlap section. But as you get more used to it, you can just do the overlapping. So with our overlapping, that's the only section we're looking at. It starts at -6. That's a closed circle, so that would be a bracket. It ends at 1, so that would also be a bracket. So in these, there won't be any infinities. It'll just be number to number. One other thing about and inequalities is because the solutions usually fall between two endpoints, they're frequently written in a more condensed form. So I'm going to take these two inequality answers and put them here. X is greater than or equal to -6 and x is less than or equal to 1. We would write it as we would start at the lowest, the -6, and then you're going to use less than or equal to symbols. X less than or equal to 1. This is saying these overlap between -6 and 1 to include -6 and 1. Solutions could be anything in between that. Before we move on, what questions do we have about any of that? So let's try some examples so you can put all that into practice. So for our problems, our quiz, our tests, our practice problems, all of the and problems will look like this. There's a reason I keep saying our stuff, because when I show you the Khan Academy stuff, it'll be a little different. So for this is an and inequality. So I would solve this opposite of how we did our ors. What we do here, we do to everything. So we're trying to get the x in the middle by itself. So we have to get rid of the 4 by subtracting it to all sides. So we have -2 is less than or equal to x, which is less than 5. That would be our and inequality answer. From -2 to 5. And then you could do one or two things when you graph it. Either just graph this, so that would be starting at -2, ending at 5, draw a line that connects them. Or if you wanted to see or make sure that is indeed where they overlap, you would have to look at this piece by piece. Cover up like half of it. Just read this part. X is less than 5 would be an open circle at 5 going to the left. Then read this part, but read it backwards. X is greater than or equal to -2. That would be a closed circle going to the right. So you can see that overlap where they would overlap. If solving it all together is complicated or complex, you could separate it by doing this. Taking what it equals or the n on one side and then writing the other one as a separate thing. So So if you wanted to solve them as two separate things, you could do that. If you separate them, that's where you're going to end up having two separate arrows and would still have to draw in the third. Where do they overlap? If this is okay with you and you just want to draw where they overlap, that's also fine. So end goal, you need to know where they overlap. Right. Interval notation, where they overlap would start at -2. That would be a bracket because it's close. It would end at 5, but that would be a parenthesis because it's open. So for your and inequalities, you could have bracket, parenthesis, bracket, bracket, parenthesis, parenthesis. Might be a mix, might not be. What questions do we have on that one? Let's do one more of these, and then we'll do any problems you guys want to go over. Let's do number 10 at the bottom. So for number 10, again, we have two different ways to go about solving this. I'll come back and show you the second one in a moment. We could start off by distributing. We have -2 is less than 2x minus 12 is less than or equal to 4. And then how would we start solving this if we're trying to get x by itself? Brian? So we would end up with 10 is less than 2x, which is less than or equal to 4. I didn't add 12, sorry, 16. Great, and then from there we're going to divide everything by 2. So that we have 5 is less than x, which is less than or equal to 8. Before we graph this and do the interval notation, I just want to show you what would happen if we had a negative instead on the inside. So I'm going to take this and just make the 2 negative just as a example to show you. So if the inside was negative, we would still divide everything. But because we're dividing by negatives, all of the signs would change direction. But we still want the inequality to make sense. Because right now, -5 is, sorry, there's 8. -5 is greater than -8 is true, but some of it is not. So all of it, when we write our and inequality, is always less than, so we would just rewrite it. So if something happened where you got this, where the signs change direction, you would flip the entire thing so you're rewriting it so that they have less thans instead. Or less than or equal to's. Okay. But we can graph this from 5 to 8. This was just a just in case example. Open circle at 5, close circle at 8. Sometimes your lines are really short, sometimes they're long. It depends on the problem. If you want to do where they overlap, you can. Just remember to read this part and then read this part backwards. And then our interval notation would be what? Where does it start?
5, 8 with a bracket.
Would they both be brackets?
The 8.
The 8 would be a bracket, the 5 would be in parentheses. Just like that. After you've written this down, 1, do you have any questions on that problem? Oh, I still need to show you the other way. We'll do that here in a second. So do we have any questions on this at all so far in general, specifically, Ryan?
The one you wrote in red,
Mhm.
and it's on the very bottom. Why did you switch on
Flip it, just because in general, they're always written less than, not greater than. Is really the only answer I can give you. The rule says, yeah. Any other questions on that one? Okay. Where you have space, I'm going to show you the other way you could do this. So I'm going to rewrite -2 is less than 2 times x minus 6 is less than or equal to 4. So just like the other problem we did where we could have divided both sides by -3, same thing here. I can divide each piece by 2 since they're all divisible by 2. So that would change this to a -1 is less than x minus 6, which is less than or equal to 2. Then we would solve from there. Adding 6 to both sides, to all sides. So 5 is less than x, which is less than or equal to 2. So you get the same thing either way. But this only works if you can divide everything by the same number. If you can't, then you end up with fractions. You don't want that. If you can avoid it, I should say. Great. Look through this page, the last page that we did, and then the very last page. See if there are any problems you want to see, go over, have questions about, not sure where to start, anything like that. Allison. 3 on the page we were already on the very last page. Okay. Any others? Come in. 1 on this page or the very okay. Any others? Alright, so let's do 1 and 3 on the very last page. Notice that these say or. So or inequalities say or, so you don't have to guess which one it is. If it says or, you are automatically solving them separately. So for this one, we would subtract 1. For the other one, how would we get rid of the fraction? What would we do to it? What do we think? How would we get rid of this fraction? It's right next to x. Are we allowed to divide the fraction, guys? So you can divide by a fraction, but we would rather do something else. Not change it to a decimal. Multiply by what, though? You're close.
Is it like you put it on this?
Yeah, right.
Yeah, we gotta put the fraction and then multiply.
So multiply by the reciprocal is what that's called. Flip it, multiply on both sides. So we have x is less than negative 24 over 4, negative 6. Keep your or between your inequality answers. Graph them both. So we have is greater than or equal to 2, is less than negative 6. So interval notation, where does this start? Keeps going all the way to the left. Where would that start? Negative infinity. Stops at negative 6 with a parenthesis or a bracket. And then starts again at 2, parenthesis or bracket. And then it keeps going towards positive infinity. So your or interval notation will always look like this. Your and will just have 2 numbers. So then 3 is going to be very similar. Solve the one on the left. It doesn't matter if you solve the one on the left or right first, as long as you do them both. I'm going to start with the one on the left by subtracting 9. Dividing both sides by negative 2. The sign changes because we divided by a negative. And then solve the other one. Get rid of your 13 by subtracting. Take your fraction, flip it, multiply it on both sides. Okay, so if your answers are like spread out like this, either rewrite it so it has the or just write the or and draw arrows. Either or. Graphing this, we have x is less than 4. And x is greater than or equal to 7. Okay. Other questions on this? I'm going to show you an example of both the and or concatenates. So on the very back of your notes, write this down. So this one is an and. So write these two inequalities down. Negative 25x plus 175 is greater than 225. 5x minus 83 is greater than or equal to negative 73. So even though with ours, an and inequality is usually condensed, this one is not. So you would you would solve it separately, but the end result is still going to be overlapping. So solve them separately Subtract 175 to both sides on this one. Divide both sides by negative 25. The sign is going to change direction. So we have x is less than negative 2. Some of these problems will give you fraction/decimal answers. Some of them won't. It just depends on the problem. Then solve the other one. Add 83 to both sides. We have 5x is greater than or equal to 10. Divide both sides by 5. And for me, I'm a visual person, so it really helps me when I see this drawn out. So I'm going to draw the number line of this. So it would be less than negative 2 and greater than or equal to 2. If this is an and, right now it's looking like an or from our stuff. If this is an and, we're still looking for where does it overlap. No matter what, does it overlap? So if it does not overlap and it's an inequality, there would be no solutions. I'm trying to exit so you can still see it. Anyway. So if it's an and inequality and it does not overlap at all, no solution. Some of the other choices were, this should have told you this would not be the right answer because this is or and we're dealing with and. If they both happen to overlap, so let's say this one went this way instead, then they would overlap everywhere from negative 2 on. So that would be x is less than negative 2. Or if this one went the other way, then they would overlap starting at positive 2 and on. So that would be everything greater than 2. There is an all solution. That would mean they would have to overlap everywhere. If they don't have overlap everywhere, that could not be an answer. Questions on this one? On the Khan Academy, the and is pretty straightforward. It's where they overlap. It's the or that's a little complex. You see that I was doing this earlier and I got one wrong. Alright, so write this one down. Negative 15x plus 4 is less than or equal to 109. Or negative 6x plus 70 is greater than negative 2. So, or for us is they don't overlap, they can't overlap. Or for Khan Academy is where, not where they overlap, but it's called the union, where both of them are true. But we'll talk about that here in a second. So still solve them separately. So subtract both sides by 4. Divide both sides by negative 15. We have x, the sign changes, is now greater than or equal to 7. Then the other one, we would subtract 70. So negative 6x is greater than negative 72. Divide both sides by negative 6. The sign would change direction. And then again, I'm a visual person, so I need to see this. Oh, this was negative 7. Okay, so you may want to like skip numbers. You could write from negative 7 to 12, but it would be a lot. I'm going to skip 5 to... I ran out of space. So then 12 would be there. Okay. The number lines depend on your numbers. So for this one, I'm going to graph them like normal. X is greater than negative 7 would be closed to the right. X is less than 12 would be open to the left. For OR, because it's the union, it's looking for where are one or both of these true. So this is true everywhere greater than negative 7. This is also true everywhere less than 12. So because that would take up everywhere, because past 12, this is going to keep going. Past negative 7, this one keeps going. It would be true everywhere. So this would be an all. So when you look at the ORs, you have to ask yourself which one of these answers would make either one or both of these true. And that'll be the most complex one. So if you need help when you're doing that one, feel free to ask. Do we have questions on that one right now?
Is it all true or both true?
It's one or both. That's why it's a little confusing. If I should say both. Both have to be true. So if I solve both and I get these two things, x is greater than negative 7 applies from negative 7 to infinity. X is less than 12 applies from 12 to negative infinity. So that means we've covered all the numbers. Okay. So for the rest of class, you can be practicing this Khan Academy that's due next week. If you haven't done tomorrow's Khan Academy, you can be doing that. Practice from the notes, any of those, and if you have questions, let us know. We will be around.